The third type of cells are called fuel cells. These are the cells in which the energy released in the combustion of fuels is directly converted to electrical energy. And hydrogen and oxygen cells is the best example of the fuel cells. Remember, these are the cells which are having the highest efficiency of about 60 to 70% with no side products or byproducts, and they are the ones which are used in the space shuttles and spacecrafts, and especially in the International Space Center. Now the best benefit is the byproducts. Let us see first what happens in this type of a cell. The anode used is of hydrogen and the cathode is of oxygen, and the electrolyte used are alkalis, hydrogen hydroxide, sodium hydroxide or potassium hydroxide. The hydrogen diffuses and it combines with the OH minus ions, gets what? Oxidized to water and forms and releases electrons. So this is what is the reaction which is happening at anode. From the other side, the oxygen diffuses, it accepts these water and electrons, gets reduced to OH minus ions. Now the electrons accepted by it are 4, electron released by hydrogen are 2. So in order to balance this, we will multiply it by 2 so that it gets cancelled. So what we find is, now since it is balanced, now it is multiplied by 2, we will be having twice of hydrogen plus oxygen. Now you can make out 4 OH minus ions consumed, 4 are formed, they also gets cancelled. 2 water are consumed, 4 are formed, so net 2 are formed. So we can write 2 water are formed. So this is what is the net reaction which takes place in the fuel cells. The cell gives a constant voltage output of 1.1 volt till we keep on supplying hydrogen and oxygen. And this is what is the reaction. Now you can clearly see that hydrogen and oxygen are the 2 substances which are consumed, and the byproducts are water, which are actually being used by the astronauts for the drinking purpose then after the mineral treatment. So this is the best cell we have. The only problem with the cells is that it uses hydrogen as one of the anode, which is actually highly inflammable. Otherwise, it could have been used very easily for the commercial purpose also. So this is what is your fuel cell. Corrosion. Corrosion is a spontaneous degradation or decomposition of a metal to its oxide or hydroxide or a carbonate or a sulfide when exposed to air and water is called corrosion. We know whenever the metals are exposed to air and water, they react with the oxygen and the other gases which are present around them, and that is why when they get in contact with the water, they get changed to their spontaneous to their oxide or hydroxide or carbonates or sulfides, etc., and this decomposition or degradation to these compounds is called corrosion. Now corrosion of iron is of utmost importance because iron is a very economically important metal, and that is why corrosion of iron is called rusting. Now in our syllabus we have to understand, there in the syllabus, basically understand how rusting or corrosion of iron takes place. See, rusting of iron is a very complex redox reactions which takes place when Fe, the surface of the metal, it gets exposed to air and water. So it's almost just like this. If this is the Fe metal and it gets exposed to this water, now series of reactions takes place. Like what happens is water gets combined with the CO2 and forms H2CO3 carbonic acid. This carbonic acid slowly releases H plus ions and form carbonate ion. As a result, the water which is present on the surface of the Fe gets acidified, it becomes acidic. Now due to the presence of these H plus ions, the Fe gets oxidized, which involves a reduction potential of minus 0.44 volt. Now who is there to accept these electrons? It is this oxygen, these H plus ions, which in presence of oxygen accepts these electrons and form water, and the reduction potential of this reaction is 1.23 volt. So what we find is this becomes your anode, this becomes your cathode, they together forms a cell with an output of 1.67 volt, cathode minus anode. So we can clearly imagine that how spontaneous this process will be, whose cell potential is this much, which is formed, which is actually happening at the surface of the iron metal. Now, further what happens is, this ferrous ions combines with the oxygen in presence of water, and it gets further oxidized to ferric ions and releases more of H plus ions. It is actually it will be somehow like twice of this, half of this, and it will be 4 times of this. So the ferrous ions forms gets further oxidized to ferric ions, and then what we find is that these ferric ions combines with water to forms Fe2O3.XH2O, which is what is your rust is. So this is a whole complete 6-step rusting of iron, and due to which iron gets converted to its hydroxide in this form, in the form of the rust. Now let us see how we can prevent rusting. Rusting can be prevented by the following measures. We can do what it can be done in 3 ways: by barrier protection. In this, what we do, we put a barrier of a layer of an oil or a paint or of a grease between the metal surface and the air and the atmosphere, water, so that the metal surface is stopped from getting exposed to the air and water. The second type of protection is called sacrificial protection. In this, what we do is, we cover the surface of the iron with more reactive metals like zinc. Now, the moment we do it, it's called galvanization, like the galvanized sheets one we uses in our water coolers. And that is how zinc, being more reactive, always prevents the iron from getting oxidized, and this is how we can prevent the rusting of iron. Similarly, chromium plating and nickel plating are other examples of the sacrificial protection, where we do the electroplating of the iron with reactive metals like chromium and manganese and etc., or of nickel. Third protection is cathodic protection, in which we connect iron with more reactive metals like magnesium, aluminium, etc., which, being more reactive, always reduces Fe if it gets oxidized, and they make it cathode, and they itself acts as a node. That is why it's called cathodic protection. So by using any of these methods, we can prevent rusting, which is a very economical process, because it is related with the iron, which is the most economical metal we use in our day-to-day life.